We are just over 2 minutes away from launch, and John will now take us through the final pre-launch preparations and through liftoff of Eutelsat 3D. John?
A nice shot of the payload fairing today with the Eutelsat logo on there. And we're currently about a little under 2 minutes away from launch. Very clear night. We should have an excellent view of the vehicle heading downrange. Now, today's launch of the Eutelsat 3D satellite on ILS Proton is the result of an accumulation of an extremely large amount of hard work and long hours by everyone on the launch team. And they're all out there in Baikonur eagerly awaiting the liftoff. All the teams should be in their places in the launch bunker, in the control rooms, in the ground stations, and the comm centers throughout the globe. And at the final go for launch polling, as we mentioned earlier, is being completed at this time. Last rays of sun on the payload fairing there. Now, in addition to those at the launch site, there are many others watching who have played an important role in the Eutelsat 3D mission, and we'd all like to say thanks for all your hard work in getting to this moment. And that includes the team at ILS headquarters in Reston, Virginia, our Krunichev colleagues in Moscow, Eutelsat Communications in Paris, France, and that includes some ILS special guests who have joined the Eutelsat team in their large auditorium to watch today's events. And Thales Alenia Space in Cannes, France, the makers of the Eutelsat 3D satellite, and all others who have helped to make today's launch a reality.
And now just a really quick note, as the ILS Proton travels easterly downrange, our viewers are going to notice some time lags in our reporting of key mission milestones. The reason behind this delay is that the Proton follows its pre-programmed flight path. It gets out of range of our receiving stations, so it might take a little bit, but we'll get those updates to you as soon as we can. And now we're getting very close to the last few seconds, John.
Yeah, we're currently around T-minus 15. We're standing by final 10 seconds here. 9, 8, 7, 6, 5, 4, 3, 2, 1. And ignition. Ignition start. And we have liftoff of an ILS Proton rocket from the Baikonur Cosmodrome in Kazakhstan with the Eutelsat 3D satellite on board. Now, it can be a little difficult to see due to the fact that it's nighttime there in Baikonur, but about 10 seconds after liftoff, the rocket does do a roll maneuver and is going to soon experience maximum dynamic pressure, which is also known as max Q. Now, that's the maximum aerodynamic load on the vehicle, and for Proton, it corresponds to about Mach 1.6 and occurs about 1 minute and 2 seconds after liftoff. Beautiful shot of the first stage engines as it heads downrange. Now, everything seems to be proceeding nominally as the vehicle heads across the Cosmodrome vertically in a northeasterly direction with a flight launch azimuth of approximately 61.3 degrees. A little bit over a minute in, we've just gone through max Q. You can see through that large plume of condensate that happens every launch. About 1 minute and 15 seconds from liftoff. First stage will continue to fire for about another 35 seconds. Beautiful night there. The rocket went no clouds to obscure the view. I'm sure the launch teams are extremely excited right now, probably feeling the rumble of the engines as they pulsates through their chests. Now we're coming up on the first stage separation from the second stage, and that's set to occur about 2 minutes into the flight. Now watch for the halo effect as the second stage engines ignite prior to the separation from the first stage. And there it goes. And we have confirmation of a good separation between the first and second stages. And, you can see on your screens there the first stage falling away with a little trail of light, and with the second stage engines all firing, pushing Proton down its path along the flight path. And we have a signal of ignition on all 4 second stage engines, and they will burn for a total of about 3 minutes and 27 seconds. You can still see stage 1 tumbling away as it's completed its job. beautiful star and the new star in the sky above Kazakhstan, heading downrange. And again, I've received confirmation of first stage separation and second stage ignition. Now, the next key mission milestone will be stage 2-3 separation at L plus 5 minutes and 27 seconds. And 20 seconds after that, the payload fairing pyros will fire, and that will separate the two halves of the payload fairing as they are jettisoned from the vehicle.
John, thank you so much. Now let's take a chronological look at Eutelsat 3D's journey to launch.
Typically, it takes about 2 years for the launch vehicle and satellite to be built, tested, and shipped to the launch site. From crew and spacecraft arrival, it can take from 4 to 7 weeks to complete a launch campaign. Today's launch campaign begins with the early team arrival in Baikonur. The spacecraft arrives aboard an Antonov cargo jet at Yubileyny Airfield. The spacecraft is offloaded from the plane and placed onto a railroad car. The thermally controlled rail car is hooked up to maintain the proper environmental conditions for the spacecraft during the 6-hour trip to the launch processing facilities. Once in the high bay, the spacecraft team does a series of systems tests and other standalone operations, including fueling the spacecraft. Fueling of the spacecraft is then completed. The satellite is then mated to the BRIES-M upper stage and rotated horizontally to be encapsulated in the payload fairing in Hall 101. The spacecraft, fairing, and upper stage are now referred to as the ascent unit. The entire assembly is mated to the booster stages of the ILS Proton launch vehicle in Hall 111. The integrated launch vehicle is rolled to the BRIES-M fueling station, where fueling of the BRIES-M is completed. The complete rocket rolls out to Launch Pad 39, where the entire vehicle is turned up vertical from the railcar by large hydraulic erectors. Then the service tower is moved in to protect the vehicle. As this is going on, it also provides a good opportunity for the mission team and customers alike to have pictures taken with the ILS Proton in the background. Proton rollout to the pad always occurs at exactly 6:30 in the morning, corresponding with the precise time the vehicle for Yuri Gagarin rolled out in 1961, marking this landmark anniversary in space advancement.
The Eutelsat 3D mission team for this ILS Proton launch is made up of representatives from ILS, Eutelsat, Khrunichev, and Thales Alenia Space. Here is the first in a series of messages from the Eutelsat 3D mission team from Dr. Vladimir Bronfman, Khrunichev Program Director for the Eutelsat 3D launch.
I'm Vladimir Bronfman, and I'm W3D Program Director from Khrunichev Space Center. Today is the morning of May 11, 2013, and the ILV, comprised of the launch vehicle, BRIES-M, and W3D spacecraft, was rolled out to the launch pad. This is a result of 1.5 years of an intensive joint work with our colleagues in Moscow, Cannes, and Reston. A large scope of design and analysis were conducted during these years. A lot of tests were done. All the results are positive, and everything is in strict compliance with international and national standards. We are very thankful to Eutelsat, our customer, that we had many programs with them during the last few years. We're also very proud of our cooperation with Thales Alenia Space, the world leader of the spacecraft manufacturing, and of course of our cooperation with ILS. I would like to note that W3D launch is the 80th Proton launch in cooperation with ILS. There are 4 days of intensive work on the launch pad ahead of us, and we believe that good fortune will stay with us.
We are just 7.5 minutes into flight and coming up on some important milestones. So let's go to John now. What can you confirm for us?
Well, Jennifer, while we were listening, Dr. Bronfman sent his greetings. I did get confirmation of second and third stage separation and good separation of the payload fairing. And currently the third stage is now ignited and doing its job.
Very good, thank
now,
you.
I'm sorry, payload fairing jettison does occur at about a velocity of about 4,600 meters per second, or about 2.5 miles per second at an altitude of 140 kilometers. Now, our next major milestone happens in about 4 minutes, and that will be the separation of the Proton's third stage from the Breeze-M upper stage.
Thanks, John. Now let's hear from Eutelsat 3D Program Manager Christophe Duchesne about today's Eutelsat 3D mission.
Good evening. I'm Christophe Duchesne and I am the Eutelsat 3D Program Manager. I'm glad to make this video today because I know that when you will be watching it, we will be at the end of 2.5 years of efforts by the team of Eutelsat, Thales Alenia Space, Khrunichev and ILS, who have been involved in the definition, design, construction, test and preparation of Eutelsat 3D for the launch. I would like to thank all the people from this organization and their subcontractors for the great job they have done to date to arrive at this point close to the beginning of life of Eutelsat 3D. It has required a lot of hard work to be here, and there is more to come with the launch, the orbit raising, the in-orbit test, and of course many years of operation. 9 hours and 13 minutes after liftoff, Eutelsat 3D will be separated from the Breeze-M. I have a special thought for the teams of Eutelsat and Thales Alenia Space located in Rambouillet that will take over for the layup. There's a lot of satisfaction working in space industry with people that are not only highly skilled but are also enthusiastic and enjoy what they are doing. Eutelsat 3D was not an exception to that, and it has been especially evident during the launch campaign where people from the different organizations have worked together to get Eutelsat 3D integrated onto the Proton-M Breeze-M ready for the launch. I'm proud to have been part of it, and I look forward, as I'm sure you are, to see the confirmation of the results of everybody's efforts.
ILS Program Director Bertrand Moncouquet sends this greeting recorded earlier in Baikonur.
Welcome to Baikonur. I'm Bertrand Moncouquet, the ILS Program Director for the Eutelsat 3D or W3D mission. We've been here since a month now with, as you can see, a very good weather, and the campaign went very smoothly. I want to thank all the participants, first the customer Eutelsat, and also the spacecraft manufacturer Thales. But for Khrunichev, I want to give a very, very special thanks because they had to work during their holidays and everybody was there to support us. Now, as you can see, the launch vehicle is on the launch pad and we will launch soon. But as you can hear me, the launch is already in progress. So it's very simple for me. Thanks you all, Reston, Baikonur, and go ILS, go Proton, go Breeze-M, and go Eutelsat W3D.
We are now a little over 11 minutes in, and we'll go to John now to get the current status of the mission. John?
So Jennifer, the Proton first 3 stages have done their job, and they have all been jettisoned, and we currently have confirmation of stage 3 shutdown, separation, and orbital unit separation. And now we'll be waiting for the Breeze-M to start its job for the first of 5 burns.
Very good, John. Thank you so much. The Breeze-M upper stage is restartable for mission optimization and is compatible with all major commercial spacecraft platforms for dedicated single and multiple launches. The Breeze-M can support dual-use satellites and satellites with hosted payloads, and even has the capability to build and serve space stations. Let's learn more about Proton's Breeze-M technology and its role in the Eutelsat 3D mission now.
We are coming up on stage 3 separation from the Breeze-M. The spacecraft, together with the adapter, separation system, and Breeze-M, are called the orbital unit. At the moment of separation, the orbital unit will be traveling at about 7,300 meters per second, or more than 16,000 miles per hour. About 1.5 minutes later, the Breeze-M will ignite for its first burn. That burn will last about 4.5 minutes. About 4 minutes after the end of this main engine cutoff, or MECO, the vehicle is scheduled to go out of range of our ground tracking stations. we will lose communications for about 70 minutes and then reacquire the signal again right after the second burn of the Breeze-M.
Here's a little about Eutelsat 3D and a video prepared for us by Eutelsat.
So since we last updated you, I do have a confirmation that the first Breeze-M burn has started, and it's currently nominally operating.
All right, John, thank you for that update. All Proton rockets are manufactured at Khrunichev in Moscow and then transported to Baikonur via rail car, as you saw earlier in our mission timeline. Here's a brief look at some of the engineering behind the Proton launch vehicle. The total height of an ILS Proton is between 184 and 191 feet, around the same height as a 19-story building. Its gross liftoff weight can be around 705,000 kilograms, or 1,554,000 pounds, depending on payload and fuel weight. Proton's initial launch was on July 16, 1965, via the Proton-1 spacecraft. If we begin our in-depth look at the Proton in a manner chronologically consistent with the launch phases, we see that the first stage consists of a central tank containing the oxidizer tank, surrounded by 6 outboard fuel tanks. Each fuel tank also carries one of the 6 RD-276 engines that provide first-stage power. Total first-stage vacuum-rated level thrust is 11 meganewtons, or 2.5 million pounds of force. The second stage is a conventional cylindrical design and is powered by 3 RD-210 engines plus 1 RD-211 engine. It develops a vacuum thrust of 2.4 meganewtons, or 540,000 pounds of force. The third stage is powered by 1 RD-213 engine and develops thrust of 583 kilonewtons, or 131,000 pounds of force. It has a 4-nozzle Vernier engine that produces thrust of 31 kilonewtons, or 7,000 pounds of force. Guidance, navigation, and control of the Proton-M during operation of the first 3 stages is carried out by a triple redundant, closed-loop digital avionics system mounted in the Proton's third stage. The Breeze-M upper stage is powered by 1 pump-fed, gimbaled main engine that develops thrust of 20 kilonewtons, or 4,500 pounds of force. It is composed of a central core and an auxiliary propellant tank, which is jettisoned in flight following depletion. The Breeze-M control system includes an onboard computer, a 3-axis gyro-stabilized platform, and a navigation system. Finally, the payload fairing. It consists of 2 symmetrical payload fairing halves and a static envelope diameter up to 3.87 meters. There are multiple payload fairing designs presently qualified for flight, including standard commercial payload fairings developed specifically to meet the needs of ILS customers. The payload fairing for commercial launches aboard an ILS Proton separates at the nose cone in a planned maneuver, leaving the Breeze-M and the spacecraft, together known as the orbital unit, to continue the journey to its planned orbit. And that is a brief look at the Proton and its stages. The Proton rocket is able to lift very heavy payloads into orbit. Proton launched Russian interplanetary missions to the Moon, Venus, Mars, and Halley's Comet. Proton also launched the Salyut space stations, the Mir core segment, and both the Zarya, meaning dawn, and Zvezda, meaning star, modules for today's International Space Station. Proton is a powerful rocket with the first stage engines producing 2.4 million pounds of thrust at sea level. Let's take a moment to learn more about the development of Proton. The Proton is a heritage launch vehicle with a long and significant history in space. Here are some quick facts. The Proton is the largest and most powerful Russian launch vehicle in operation. It has launched more than 380 times since the mid-1960s. Khrunichev State Research and Production Space Center, the majority owner of ILS, is one of the pillars of the global aerospace industry and manufactures both the Proton rocket and the Breeze-M upper stage. While the first Proton mission was in July of 1965, the first commercial Proton launch took place almost 30 years later in April of 1996 with the Astra 1F satellite for SES. The UR-500 vehicle's first 3 payloads were spacecraft called Proton-1, 2, and 3, and subsequently, the launcher was named after its original payload. Khrunichev manages federal launch missions while ILS offers the Proton for commercial satellite launches. There are about 7 to 8 commercial missions a year and 3 to 5 federal missions per year, with 3 active launch pads from the Baikonur Cosmodrome in Kazakhstan. As John indicated earlier, through communication with the Baikonur control room, we are at the point in the mission now where the Breeze-M upper stage is just getting started. A total of 5 burns will be required before we get to spacecraft separation. So John, what is the current status of the Eutelsat 3D mission?
Everything seems to be nominal, moving along its flight path as planned. A few minutes from now, the Breeze-M will enter a planned blackout period. Now, that's when the vehicle is currently out of range of any of the designated Russian tracking stations. And we will not be scheduled to be back in communications again until after the second burn is completed, which is about an hour from now, but I'm sure you want to know, but the main engine cutoff for the first burn has completed successfully.
All right, John, thank you very much. Eutelsat 3D manufacturer Thales Alenia Space is represented by Eutelsat 3D program manager Jean-Christophe Chotard.
Hello, my name is Jean-Christophe Chotard, and I'm W3D program manager for Thales Alenia Space. Right behind me is a rocket, and on top of this rocket is a very nice piece of work called W3D. W3D, obviously you can't see it, but I can tell. This is a nice spacecraft manufactured by Thales Alenia Space for Eutelsat. W3D is a 2-year story, which I'm very proud to have been part of. Now, the last few weeks here in Baikonur went very nicely and smoothly, and I want to thank and congratulate all the teams here who participated to these operations. And I mean ILS, Khrunichev, Roscosmos, Thales Alenia Space, and Eutelsat, of course. Now, W3D story doesn't stop here. Of course, there is a follow-up. We have teams, Eutelsat teams and Thales Alenia Space teams in Rambouillet, in Cannes, who are going to follow and control the spacecraft right after separation from the launcher. So guys, I know you're the best. We wish that you will do an excellent work. We count on you, and I want to thank you all and congratulate you. Finally, I want to thank Eutelsat, whom Thales Alenia Space has the privilege to have as its customer. Thank you very much, and go W3D, go!
Before we wrap things up, ILS's very own Bertrand Moncouquet, who is the ILS program director for the Eutelsat 3D launch, is an avid photographer. While we tell you a little bit more about Bertrand, we will show you some of his photography works. In his own words, he says, "I don't think I'm a good photographer, but I may have a good eye to find something interesting or beautiful. It was a kind of hobby when I was young, and I learned by practice and reading. I like to report about the campaigns with more than words and to be able to get some shots in such a different environment." It's beautiful. He has worked on 8 campaigns with ILS. Bertrand is also the program director for the SES-6 mission, which launches in June. So very nice work, Bertrand. Look at that from the market. So what has to happen after the Proton flight in order for the satellite to become operational? Well, for that we go to John.
Well, our broadcast takes us through the first BRIES-M burn. Now, after the broadcast completes, the BRIES-M will continue to execute 4 additional BRIES-M burns before separating the spacecraft into a geostationary transfer orbit. At 9 hours and 13 minutes after launch, the ILS Proton will have completed its mission, and Eutelsat and their contractors will then take over the operation of the satellite from that point forward. The spacecraft will then execute a series of planned operations over the next several days, which include solar array deployment, reflector deployment, and a series of apogee engine burns. Now, these burns will bring the orbit inclination down to 0 degrees and will raise the perigee to match the apogee. Now, that results in a circular geosynchronous orbit over the equator. Now, following a period of in-orbit testing, the spacecraft will settle into its operational slot of 3 degrees east and begin to provide service to its customers.
John, thank you for that. Now remember, you can keep current on the Eutelsat 3D mission by visiting the ILS website, ilslaunch.com, by following us on Twitter, or by liking us on Facebook. Also at ilslaunch.com, you can check out pictures of past ILS Proton launches as well as the current mission, read blog posts from the ILS mission team, and learn more about ILS and its mission.